That's life. You ready?
No.
Are you ready?
No.
Let's go!
Damn.
Ja! Just kidding. Okay, we got a zip line, right? Let's draw a picture. What does a zip line look like? Goes like this, right? Now, what it's saying is that it has a zip line ratio of 3, because the fall is 3 and the run is 5, right? That's the zip line ratio. It also says that the zip line is 100 feet long, right? And it's 10 feet off the ground, or at least higher than where you land. Does that make sense? Is that possible? Well, I don't know. We're going to find out. So, give a linear equation for the zip line. Give a linear equation for the zip line. And I think what they meant by the 100 feet to the end of the zip line was not it's 100 feet long, because that would be the hypotenuse. I think what they wanted was to be 100 feet to the bottom of that zip line. Does that make sense? So now it's 100 to 5 and 10 to 3. Okay? I think that's what they wanted. But that's not the same ratio. That doesn't work. Give a linear equation for the zip line. How high do you need the zip line to be attached? How far is the base of the end of the zip line away from the start of the zip line? So, they are saying that this length is 100. So this length is 100 feet. Okay, this sounds really weird. Alright, so, the first things first is, we need to figure out how far this is. Right? Because I can't write the equation if I don't know the slope. But do I know the slope? What's the slope? 3 to 5, yeah. So I actually do know the slope. What's the b?
The what?
The y-intercept. Wouldn't that be this? 10? So, we could write an equation for this. Okay? We could say, hey, if this is given, right, we can use our definition of y equals mx plus b, right? Definition of y equals mx plus b, so that this is y equals x. What's m? 3/5. What's b? 10. And there's your equation of a line. So that's the first question. Can you write an equation of a line? Then they say, how high up does the zip line need to be attached? What they're saying there is, if this is your zip line, right? And you have 100 feet, right? Long zip line, and it's 10 feet off the ground. Is that going to work? Right? Oh, the end of the zip line is 10 feet off the ground. I was getting confused because that just does not work. The end of the zip line is 10 feet off the ground. I was like, that doesn't work. It doesn't work. It's not the same slope. If I know that this is 100, right, then I gotta find out what this is. What is this? That's the only way I can find similarity, right? Now the slope is going to be the slope, but the b is not going to be 10, so therefore I cannot do that. Okay? I need to find how high this is before I can do anything, right? But to find out how high that is, I have to find out the ratio. What do I do? What do I multiply this number in order to get this? Once I have that ratio, because these are similar triangles, I can times that same number by this to get this. I can times that same number by this to get this. Does that make sense? Okay? But until I do that, I can't do it. So, first step. Yes, they give us a slope. Given. But I can't do definition of y-intercept. I have to do Pythagorean theorem, right? I have to do 3 squared plus 5 squared equals c squared, whereas this is c. Does that make sense? The first step I got to find is c, okay? And that is definition of Pythagorean theorem, okay? So, what is 3 squared? 9. What's 5 squared? I don't care what they say about you. You're smart. 25? Come on, people. Give me some numbers, man. Alright, here's an easy one. What's 9 plus 25? There you go. Now I messed this up one year and I wrote 36. Then it was easy to find C, right? But it was wrong. So, yes, it's 34. Can we break 34 down? Well, we can. We're going to do, oh, by the way, what did we do? We did substitution, right? We did exponential simplifying. We also did simplifying, right? And now we're going to do exponential solving, right? So the square root of 34 is equal to c. Okay? Now I can find a number for that, but we don't need to. We can just use that, okay? Now, how do I compare that? What times 34, square root of 34, equals 100? How do I do that? So we know that similar triangles, because this is a right triangle, okay? Because this has the same slope, then this is going to be similar to the whole piece. This is going to be similar to that piece. Therefore, we can use similar triangles to solve the ratio problem. The ratio problem is some number x times c is going to equal 100, right? And we're trying to find this. X is our ratio. Our similar triangles ratio. Okay? What is C? So that's similar triangles. So what is C? Square root 34. Okay? So we plug it in. X square root 34 equals 100. Substitution. Divide by square root 34. I got x is equal to 100 over the square root of 34. Now you're not allowed to have 34 square root in the bottom. So we got to multiply by the square root of 34, square root of 34, and we get x is equal to 100 square root 34 over 34. Now, can we break down 34 and 100? Is there any number that goes into both 34 and 100? So, we substituted, we did the division property of equality, we simplified, and now we're simplifying some more. We're going to say 2 goes into 134, right? 2 goes into 150 times. 2 goes into 34 17 times. That is your ratio. It's not nice, is it? That's ugly. But that is your ratio. So, how do we find this height? Oh no, we're close. Remember, if you take the ratio, right, and you multiply it by the height, you'll get the new height. That is the definition of similar triangles. Definition of similar triangles. Okay? So, I can take this height, multiply it by x, and get my new height. So I can get, let's call it A. Let's call it B. Why not? Because what's B? The y-intercept, right? And that's what I need to write the equation. Remember? So I got to come back and write that equation. But first, let's solve this. Let's plug in the ratio. What's the ratio? It's 50 square root 34 over 17. What's h? 3. And that equals our new height, which is B. Substitution. Okay? Now what? Well, what's 3 times 50? Because 3 doesn't go into 17. They're both prime, right? So 3 50s, so that's 150, isn't it? So 150 square root 4, 34 over 17 equals B. That is your height. So that is just simplifying. But now we can use that y equals mx plus b definition, right?
Oh my gosh.
We have b. We have m. We have y equals mx plus b. Definition of y equals mx plus b is what? Y equals x. What is m? 3/5. What is b? 150 square root 34 over 17. That is your equation of the line. It's not nice, but welcome to real life, people. Real life isn't nice. There's nothing nice about real life. It gives you ugly numbers, so you have to be ready to attack it. Okay? Alright, next. What else did they want? They wanted the equation of a line. They wanted to...
We're not done?
No. How high is it? How high is it? So, it's not just this height. The height of the person at the top of this is what? It's b plus 10 feet. Because it's 10 feet off the ground. Right? It's b plus 10 feet. So the true height is equal to b plus 10. That is the definition of this height. Right? It's b plus the 10 feet. Okay? Then plug it in. So now you know how much it is. You can do it in your calculator, 150 square root 34 plus over 17 plus 10. Right? Okay. Next. What is this length? It's the same thing we did to find B. We're going to find the length. Let's call it L. Right? We're going to take X times L. And we're going to call it little l, right? So LL is equal to big L. In other words, 5 times X equals big L. What's 5? Right? So that's the definition of L. And substitution. 5, and what's X? X is 50. Square root 34 over 17 times 5. 5 times 50 is what? What's 5 times 50? 5 times 50, 5 50s. Come on, 5 50s. Come on, 5 50s. 250. Good job. All right. 250 square root 34 over 17 equals L. So that's how far away you are from where you live. Okay? Beautiful. Love it. Fun stuff. Is it easy? No, not quite. We'll get there. Let's go. Who loves you? Me.